Welcome, everyone. My name's Mark, and this is Mark Voids a Warranty. That's right. Each week, Friday, around noon, I take something apart and we see what lessons we can learn. You know, what's hiding inside. And I just get to destroy stuff. Now, I'll tell you a secret. I can usually put the stuff back together until I hit it with a hammer. So it's always fun. I try to do something different each week. I've got actually projects laid out for the next 3 months. So if you've got nothing to do on a Friday afternoon while you're eating your lunch and relaxing, come join me and we'll see what there is to see. This week, the Tivo has wronged me. Rawr. You see, back in the day, I recorded quite a bit of Betty White stuff. Betty White passed away. The Tivo no longer has records of any recordings. Anyways, that's reason enough to die. Besides, look at this thing. It's ancient. It's got a telephone port. Oh, wait, that's network. There we go. Phone line. There we go. So, anyhow, let's go and get started. We'll see what is inside. We're just here on the famous Mark workbench, and first thing we've got to do is get this case open. While I'm taking out the case screws and getting us access, I do want to remind you that I have the comments live, so if you're out there in TV land and you have any questions as we go through, I'd be more than happy to answer them for you. If you don't have questions, you can make up one. I mean, I make up the answers, so making up questions is only fair, right? There's quite a few of these little T-spline case screws. Just have to get those things out. Looks like there's 2 left, and we should be rolling. So I use for my overhead camera view 50mm telecentric lens for one, and then an Arducam for the other. And the nice thing is that it provides a huge working distance. I've got like 3 feet, so doing something like pulling out this Tivo gives me plenty of room. Okay. That, my friends, is a dirty circuit board. Yeah. I wonder if at all, in doing any of these Mark Voids of warranties, you would think at some point I would have learned to keep a set of gloves next to the desk. But I guess the series is called Mark Voids of Warranty, not Mark Gets Smarter. Maybe that'll be a new one. Bummer. Well, bummer for me. I guess I'll have to learn the hard way. All right, so we've got a few different things in here that we can take a look at. Obviously, we've got the power regulation and control over here on the side, so that'll give us a fun board to look at. Looks like we've got wires soldered directly to the board over there. Then over on this side, we've got the data storage, media card slots. Those are installed. Interesting. That would make repair a little difficult. Looks like we've got RF running across from the antenna in. So we've got a filter, a couple RF chokes over to where it intercepts the board over here. A very dirty, is that a Broadcom? Looks like it. Very dirty Broadcom chip. Well, away we go. First thing I'm going to do here is just disconnect the power supply wherever I can. This thing has been sitting for quite some time, so I'm not worried about any residual charge stored up in the capacitors in the power supply getting me. So that looks like we've separated the power. I might need to change drivers. Let's see. Nope. So let's go ahead and isolate this guy, pull it out. all I'm doing right now are just taking apart screws. That's an interesting... Don't know why you have all the concentric circles around all these. But makes them easy to identify and find. Just seems excessive. Maybe the Tivo engineer was feeling artsy. Okay. So we are pretty much clear. There is a remaining case screw. Where am I on screen? I know it's a little out of focus. That's just because it's sitting so tall. But there is one remaining case screw up here that I have to remove before that board will set free. And for that, I'm using my tiny little screwdriver collection. I mean, this little thing has taken apart more stuff. And as I recall, it wasn't very expensive. I will have to find that and link it. It was a good buy. Okay, so here is our first board. Got some ESD protection on it at first glance. Some dust bunnies. That's a big dust bunny. Yeah. And then we've got the board. So we'll take a look at that. That's mostly providing power for the PCB and the hard drive. So that'll have some interesting stuff on it. Now I am just going to go and find all of the screws that are holding this motherboard to the case. We'll get those out and then we'll see where we're going from there. As I go through, please feel free to join in the chat. The first thing here, this is just a FFC cable that connects the front controls and display of the Tivo. And there's quite a few case screws holding everything in. It's a funny thing with case screws. You need enough to hold the board and keep it from shifting and during shipment and life of the unit and all. But you don't want so many screws that you over-constrain the board from thermal expansion. I don't really know how you do that. I usually just guesstimate it. I don't know if there are any mechanical engineers out there that can provide us some information on the processes of constraints. But you definitely need a Goldilocks. Too much, no good. Too little, no good. One thing I'm kind of amazed by is the size of this board. This is pretty big. There are pros and cons for having boards that big. You know, some of the cons, and I'm sure this isn't big enough to be a problem, but you can't fit that many boards on a PCB panel. I'm missing screws. And another issue that you have when the boards are this big is if something doesn't work, if something messes up, troubleshooting can be a pain, so can repair. So sometimes it's good, if possible, it's not always possible, to break larger projects into smaller projects, smaller boards, so that if you do have a failure, it doesn't hurt you so bad. You just have to replace half the project instead of all of it. Unfortunately, then, you've got signal integrity issues as you try to bounce things from board to board, and that can become a problem. Okay, this is still firmly attached at the back somewhere. So let's keep taking stuff out and seeing what happens. Oh, there's the... And then we've got some attachments to the top, or to the front of the, or I guess it would be the back of the case that we're going to have to deal with as well. I know, a lot of screws, a lot of screws. You guys came here for Mark voids a warranty, not Mark uses a screwdriver. We're getting there. We are getting there. So, dear viewer, what is it you would like to learn today? Let me know in the YouTube comments, and I will maybe make that happen. So one of the issues I can see with this board actually has to do with case design. I mean, look how absolutely filthy this board is. It's got open air connections to, you know, through the bottom of the case, and then presumably an output fan. I don't know if this is an input or an output fan up front. Let me get that to you. So right up here, there's a fan. Actually, I can tell you the airflow here in just a second. Well, with no filters or anything, this thing has just been absorbing and attracting all sorts of detritus and debris. That can lead to all sorts of issues. You've got creepage and clearance on the power supply. You know, that debris can cause a short circuit. It might be a high resistance short, but it'll be a short circuit. Let's see where the arrows are on this. Where are the arrows? Are they under here? I don't see any arrows. Okay, I don't know which way that thing blows. But either way, sometimes when you're doing a case like that, you do want ample airflow. But man, could they not have benefited from a little bit of a filter on this thing? Yeah. That's all I have to say. Okay, so the board should be free from the back. So now I've got to take out the connectors to the front. Just to find the right size. So there's just a few off-board connectors that are tied to the back side of the case with some screws just to provide a little extra support. And it looks like it's a combination of two different sizes of T-splines. From a assembly standpoint, it's usually best to try to decrease the different sizes that you need your assembly line to put stuff together, but that's not always an option. I mean, unless you want to pay for some custom fasteners, which who wants to do that? All right, so what I'm doing now is taking off the RF connectors. Are these F-type? I don't remember. But they're screwed through the back of the casing as well. So I'm just loosening those up and removing them. And then if I haven't missed any case screws, that should allow this Tivo to come the rest of the way apart. We shall see. Oh, it's acting like I missed 2 screws. It's acting exactly like that. Is that the right size? Let's find out. There's, in the RCA connectors, there's a couple that I missed. I tell you. Hi, Henry. It's going well this Friday, my friend. How are you? How's your project coming along on Teach Me PCB? Oh, come on. I'm making myself look bad here. Let's get a couple more out. There we go. That's the right size. Well, thank you for joining me, Henry. Always a pleasure to have you around. Okay, that is loose. Now, the last board to pull out of here is going to be on the front of these. So there's a couple case screws that are hiding up. You know, you can kind of see one there. So we're making pretty good progress here. We're about 15 minutes in, and I've almost got it taken apart. You're supposed to be writing firmware right now. No, Henry, no! You know, I've got to figure out how to get it into GitHub, Henry, but we've got firmware for your project, provided you didn't go off script. We've got firmware from your project written by Jesse Colcago Robinson that you should be able to use or adapt pretty readily in your design. Okay, that's the end of the case. Goodbye, Mr. Tivo. Now, a few more screws. And we'll have this thing disassembled. So 3 circuit boards overall, and all of them have different specs. They were designed to do different things. The big one, the logic board, I assume is going to end up being a multi-layer board, whereas the power looks like a 2-layer, and this front panel looks like it might just be a 1-layer board. Nice thing is that the fewer layers of copper that you have, generally the cheaper your board is. So it makes sense, if you can, to split that stuff off. You know, this 1-layer board that I'm pulling out right now would be a fraction of the cost of the logic board. And that logic board, man, that looks expensive. All right, so here we go. Here is our first board out. So, nothing too fancy or ununderstandable. You've got a series of switches that are connected back through resistors to that FFC. We've got a display over here, just a through-hole display soldered just to bring it up to the surface. Other than that, the display itself looks like it's got Kapton covering for short circuits. So just a little tiny LCD. You can see all the individual traces there kind of glistening under the light. So back on the back side of that is going to be some sort of a controller IC, or maybe even built into it, I don't know. And then we've got an IR receiver. No, it's just kept up there with some foam and some sticky tape. And then just a bunch of, you know, you've got these little jelly bean parts, resistors and whatnot. Everything's just run straight traces and 45s. There is no ground layer. It doesn't matter oftentimes, especially if you have low transitions. It's just not going to emit enough RF energy to cause you to fail emissions test. So interesting. But yeah, single layer boards like this, you don't even really worry about return paths or anything along those notions. You're just trying to keep costs down. So one-sided board. Cool. All right. Next up, we'll go with the not as dirty option. So we've got our power board, bum, 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 with a bunch of wires. We're just going to get rid of that harness there, get it out of my way. And I think I'm going to put something down just so I don't contaminate the heck out of my work surface here. I know you're saying, Mark, why didn't you do that earlier? I forgot about it earlier. There we go. All right, so on our back side, you can see some pretty heavy traces in some parts, almost to the point of being copper pores. In fact, I'm pretty sure those are copper pores, at least that one, rather than traces. And you use those to deal with heavy current without heating up your board. So the designers here had this part, which I assume is a switching FET. Let's get see if I can get the heatsink free. I don't know if I can or not. It also might be attached on the other side. And then the reason this whole thing is covered in solder is the assembly process of wave soldering. So you'll put all your parts on one side, you know, and this works for through-hole parts primarily, but you can also do it with some surface mount as well. And then you run it over a tank that produces this wave of molten solder, and it coats all, you know, all metal, all unobstructed. So they do have some surface mount stuff hiding here on the bottom, and you can kind of get the makings of a little bit of discoloration here. I don't know if that's heat or what. And then we've got some high voltage discharge spikes here. So if, you know, you get hit by, say, lightning or whatever, the general idea is that it jumps these spots here instead of, you know, running through the rest of your circuit and finding another path. ESD as well. I don't really, be honest with you, I've never designed those, so I don't really know what the equations look like or what the design criteria is. Vent holes, maybe? I don't know. Sometimes you'll see slots in boards for creepage and clearance purposes. It increases it doesn't do anything for clearance, air gap clearance, but it does increase the distance that something would have to travel, charges would have to go. So putting a slit in there, you can increase your creepage standards. Dirty, dirty. Dirty birdie. So energy comes in here. We hit a transformer. Looks like, is that a rectifier? That's our rectifier. So this gives us DC. And probably from DC, we're filtering it out there to get a nice smooth DC. And then we go into our switcher, our first switcher. I'm guessing some sort of a power management IC. Then from there, or do we go as well as into here? I don't know. But anyways, from the switcher, I'm going to assume then that we go into this transformer, and that gives us our various voltages. And we have what looks like, I can't tell without taking that apart, we might have some Litz wire. I'm not sure. And then from there, we've got other voltage regulators, some more filtering capacitors, and more switchers. Or LDOs. They could just be low dropout regulators. I'm not entirely sure. A few more filter capacitors, and then we're off and powering the Tivo and the hard drive. So, interesting little circuit. Big capacitors. I mean, other than this thing being dirty, it doesn't look that bad. Dirty. All right. What do we have over here? Now, for this guy. Yeah, I'm sorry, people. I have to. I have to do this. We can't even see what we're looking at. There's enough schmutz here for a taxidermist to make a cat. And that's just not good for anybody. I mean, in all fairness, neither is cleaning electronics with a Clorox wipe, but, you know, hey. This thing isn't going back together anytime soon. Boy, I tell you, if I did any amount of prep for these things, I would have taken this thing apart, blown it out with a air compressor outside, and then come in and been amazed at how clean it was. That would be cheating. And dear viewer, I don't like it to get caught cheating. Okay, that's better. It's not great, but it's better. Okay, so backside of the Tivo, you can make out that they didn't use this as a ground plane. They used this as a signal plane, and looks like signaling mixed power. So I'm assuming that these thicker traces they're using to route their currents around the board as they need to. This might be a fence. I don't know what that big fat trace is. It looks like it's a ground fence. Yeah, they've got a bunch of vias tying it there. And actually, you guys might not be able to tell, but I can see through this in some spots. You can kind of make it out here. Yeah, you can see that. See, you can see my finger through the fiberglass. How about that? So in this little section of the board, you can see, oh gosh, how can I demonstrate that to you? There you go. You can see an internal layer or two of copper. Isn't that cute? So other than that, they've decided to go with a copper exclusion in that area. And sometimes you do that to eliminate EMI noise. So what was over there before? I think that was our phone connection. Interesting, interesting. Let's get to a closer view and we'll see if we can't figure out anything else about that particular circuit. I don't know if we will or not, but you never know. All right, so this is the area that we're looking at. So the phone lines, and man, it's been a while since I played with one. I want to say they can crank upwards of like 90 volts when they ring, which is enough that you have to worry about it. Maybe not to this extent, but you do have to worry about it. So it looks like we go through resistors, some big fat caps, go into ground, go into one end of the line, go into the other end of the line, and then coming back over some diode. And then I don't know what this U3002 is, but based on its proximity and connection to the other components, I'm guessing that does something either with, maybe it does DTMF modulation or something else. I don't know. And then we go from there into another IC. See, that one looks a little higher density. If I had to, and it's got, oh, and it's got a, is that the DTMF? I don't know. This could be the thing that's doing the work of the modem. I'm not entirely sure. And then we've got a copper pour a ground that's running along that edge. So if I had to guess, my suspicion is that they removed all that copper. Maybe they were worried either about high voltage, creepage clearance concern. Maybe they were worried about lightning coming in and striking things and burning out the board. I don't really know. But, I mean, that was an intentional choice to keep the copper out of that area. And we can kind of see the copper pour underneath. And then you get tied back in to this ground connection here with all those vias. They created a little fence. 4-pin header that's unpopulated. I'm guessing a UART, either diagnosis or test strip. Look at all the vias they used there to tie that copper in. This thing was made back in 2006, according to the other board. So we've got a Broadcom IC. The letters and numbers here indicate that what we've got underneath there is a BGA. Couple, I don't know, don't see anything here, but I'm guessing their memory. Maybe? Hard to say, hard to say. Missing switch. That is an interesting pattern, the via ties on there. I'm kind of curious as to what those things become on the back side. That's these things here. And it looks like we're running through a resistor arrays back to one of the big chips. So why are those connected in the way that they are? Because on the other side, as I recall, they went straight through. Interesting, interesting. So these memories, if they are memories, and I'm pretty sure they are memories. I mean, that's a cute layout pattern, but I am a little bit confused as to what that does. We do see a variety of via sizes and holes here. I mean, I would say those are getting a little close together, where your fabricator might decide to start charging you money for it. And then there's a big hole here in a weird shape. I don't know why they routed that out. I mean, they certainly had plenty of room to work on this thing. If you would have given this board to someone, far more proficient than myself, like I can't think, Rick Hartley, for example, you would have come out of there with a smaller board, to be sure. But then the question is, since this board is so big, is it small enough that you're able to fit another board per panel? That's where it makes financial sense. If you can't get another board per panel, either in the X or Y direction, there's not a whole lot of point in further shrinking things, unfortunately. So it's one of those things where, you talk to your fabricator, and let's say they make 18 by 24 panels, and they want 1-inch margins for whatever reason. Let's say they're using them for your test coupons and all that other good stuff. So instead of 18 by 24, you end up with 16 by 22. Well, you can figure out how many boards, especially, with your breakaways, how many boards you get in each direction. You could get a board, 4 boards that are 8 by 11. Little less. But if you go from 8 by 11, and that gives you 4 boards, And then you go down and you get, say, 7 by 10. You still could only get 4 boards out of that panel. So what have you really saved? You've just made it harder to route. So it's something to keep in mind when you're doing stuff. Henry says, the V-shaped via pattern seems like it might branch to on an internal layout. Looked like there was more vias and traces going down below on the bottom side. Yeah, there's certainly something going on there, Henry. You know, it's taking like a T shape, and it could be that they do have things going on the bottom side. It certainly looks clean and it looks deliberate. I would just want to see the other layers to better understand that. I don't want to sit and stare at this in the, you know, while on TV, guessing. I just don't know. Okay, so that removes the mechanical connections for the cable card, allegedly, unless I missed a couple. There's some plastic bits there. Get back on screen. There we go. Now, it probably needs to be desoldered. Or, nope, it just unplugs. Well, there we go. So the cable card connection, it just does a mother-daughter board type thing. And everything else is just routed linearly. So not much to that. It just looks like they have a couple built together for that. Okay, so that was in this section of the board. And it looks like they did that so that it could get to this guy, which the Xilinx, is that another FPGA? Spartan, yep. And SCM. Is that memory for that? That looks like that's a weird IC. You guys probably can't really appreciate that on camera since you've got the top-down view. But that thing is sticking way the heck up out of the board. It's like twice the height of a normal IC. Weird. One thing to keep a note of too, sometimes we have these in, you know, these types of questions on the Teach Me PCB course. It's like, what do you do with the reference designators if you can't put them right next to the thing for whatever reason? And in this case, you just lay them out logically. So here we've got a list of 5 of them, and we've got 5 components. Guess what goes to what, right? So you've got your R601, 602, 603, 604, and R138. You just keep them grouped in a manner that lets whoever's inspecting your board or repairing your board to make sense of things. That's what you're trying to do with all of this stuff. Somebody at some point has to look at this board and or have computer vision on it. And let's say the computer identifies a missing component here. Well, which one is it? Yeah, you can go back to the design files, but you could also misread the design files. So you just try to make life easy for people. You can see a couple fiducials here. So on this big fat IC, you know, sometimes if you have small pitches, you talk to your assembly house and you find out which ones they want. But you'll put 2 fiducials so the computer vision system has a better chance of properly identifying the things and going from there. Boy, I don't know. What else is there to look at here? I mean, it really is an interesting board. And I would really venture to say it's laid out in a rather leisurely fashion. I mean, there's just vast swaths of the PCB with nothing in it. And that's not something that you typically see in modern designs, just because board space is so valuable. But like I said, if you've got, what was it, 22 by 16 inches to work with, and you have your boards at 8 by 11, until you get down into the next the next easy thing to break things up into. So I guess that would be 7 1/3 inches. It just doesn't matter because you're not going to get another, you're not going to get another board out of the panel. So why put yourself in that situation? All right, let's take a look at the RF lines here. So coming in from, well, this is a cable card. So coming in from the cable machine, you've got these guys. Let's see if they'll come off. So we've got an RF input, and I would imagine in here we're going to find some inductors and capacitors, and oh, I'm just twisting them off. Okay, well, in that case, we'll just cut them. They must be soldered on or glued on or something. Come on, big guy. Give up the ghost. So we do have some plated through holes on the bottom side there. And they are going to break away here any second now. There we go. Oh, I'm going to have to do a little more demolition. So RF circuit obviously built a little different. We've got vias everywhere. I don't know if I can get under there or not yet. I cannot. But we've got vias everywhere connecting the different copper pores. So the signal comes in, runs through what appears to be some sort of a transistor, probably boosting it. And then a variety of resistors and capacitors that are messing around with the signal path. Other side, I think we've just got a couple inductors. Just ferrite beads, not even doing much other than bleeding off some RF energy. There we go. Put that back together with ramen. All right, so here it is. Interesting looking. This whole thing's got to be some sort of an amplifier and bandpass filter. So we get all that good stuff in, boost the signal, keep it in the coax, shoot it down, and then these guys have to be some sort of a demodulator. And there's a lot more going on the receive side of those things. I don't know if we'll be able to get one out or not, but guess what? We're going to try. Where is my iron before I turn that on? Sorry, Chester. Oh, sorry, buddy. I'm sorry. I just don't want a fire. You know how I am. And then I need a holder. All right. We're going to use some Chip Quick today to take things apart. You can get this stuff on Amazon or DigiKey or anything like that. And essentially, the way that it works to desolder something, especially something this big, is we flux it. I like the syringes over the squeeze bottles just because it seems to give me a little more control. And then we're going to melt this specialty removal alloy for SMD rework. This stuff is very brittle, which is why you don't want to use it as a regular solder. But it's got a very, very, very low melting temp. Nope, am I not on? I'm not on. No. There we go. Helps to solder if your soldering iron's hot. Who knew? So we're coming, it'll come up to temp here pretty quickly. We're almost there now. But the basic idea is that you heat up all of these connectors. You melt the chip quick on, in addition to the other solder. So it just goes right over the surface. It lowers the melting temperature. And I am using it rather liberally. Then we just run back through, make sure everything's nice and hot. And then try to extract it. Oh, I missed some. Okay, so there's also mechanical right there. Is there such thing as a general purpose flux cleaner, or do I have to buy something specifically tailored for the flux I use? Yeah, Henry, there is. There is general purpose flux cleaner. You actually search just for flux cleaner and you'll find it. Isopropyl, like high strength isopropyl, works pretty well too. But you get flux in a spray can, like like you'd see for a computer duster. And that'll work out for you as well. And it works pretty much regardless of what flux, whether you have clean or no clean flux on there. USB were related to contamination inside the Type-C connector. No clean flux, very hard to clean with IPA, seems to have an invisible non-conductive layer. No clean shouldn't be conductive. It should be non-conductive. However, contamination can certainly be a problem. Oh, there's even more of these things. I tell you. I might have to pull out the heat here. But yeah, contamination can certainly be an issue. So one of the things board houses do, even with no clean flux, is they'll run your boards through a wash, specially designed wash program. If you're doing it at home and you've got components that can handle it, one of the things that people sometimes do is get an ultrasonic bath with like 99% IPA. And no, that's not Irish Pale Ale. Okay, this is a lot of stuff. I might need to get some more heat on here. Let's go ahead and do that. I didn't realize there was so much to take off. That's not the right. That is not the right rework nozzle. If this doesn't work, I'll move to a vacuum in just a second here. But yeah, that's one of the reasons that, all those issues that you ran into, Henry, that's one of the reasons I usually recommend engineers not assemble their boards at home. It's fine for us when we're doing hobby and personal projects and stuff, but, look how much trouble you had with just one or two boards. Can you imagine trying to do a batch of 100 of them? I'm just saying life's too short. This is not the right nozzle, and this is not delivering enough heat. We are going to change tools. All right. You know what they say, never the easy way. We're going to get there, though. We are going to get there, hopefully with a little time to spare. All right, so next up, we've got a Hakko desoldering iron. That's this guy right here. Boom, boom, boom. So there's a nozzle on the front of it that's going to get hot, and it's going to melt the solder. And then we hit the vacuum, and it's going to suck it off. I could use with a slightly larger nozzle, but I'll need shorter ones here. So you can see here, what I'm trying to do is actually suck the solder right out of the hole. Which requires that I actually get it over the individual pins. But when you've got a large amount of metal that you have to heat, that is one of the best ways to go. Just a little time consuming. Elliot says, if you have an ultrasonic cleaner and don't want to fill the thing with solvent, fill it with water instead, then put your board in a Ziploc bag or container with the alcohol and try it that way. Elliot. Clever, clever, toilet lever. That's what I'm saying. Where did you learn that? That's genius. So you guys might not be able to tell, I am making progress. Occasionally I'm missing one. I could do with a larger nozzle to get around these guys, but I'll deal with that in a minute after I get most of these clear. I tell you though, Elliot, your cleverness never ceases to amaze me. Okay. Well, there's still plenty more of that. All right, let's see. So this is still firmly entrenched with those mechanicals at the edge, but I still want to see what's inside those. Wonder if there's more that I'm missing here. So we might do the famous mark removal technique. All right. I could sit here for 20 minutes and I could get that off. I could. I'm not gonna. Yep, it was those edge ones that was getting me. There we go. I mean, you can kind of see on the board, I relatively cleaned out most of those holes. You can see the ones where I damaged and pulled out the through-hole via. But mostly it worked. It was those edge connectors that was holding this thing on the board. So now we've got this guy, and I'm just getting it open now. Wrong button. There we go. So I just want to get this. So Elliot says, I've seen it done for tiny objects in little containers. Okay, but I like that, Elliot. That's good. All right. So now we've got inside this nice little RF case, we've got the rest of it. So the first thing was an amplifier, linear amplifier. And its job was to, let me get this unplugged here, or turned off at least. There it goes. So its job was to amplify the signal and maybe do a little bit of bandpass filtering. This is going to do further refinement. All of those little RF coils are conditioning that signal. Quite a few of them. And each one of the little RF sections, and I am afraid I can't tell you what each one of them does just by looking at them. But each one of these things is then going through and grabbing that signal and doing something with it in a different stage. And they're trying not to let the energy from one coil leak into the other. So whenever they install these, they tend to install them at right angles to each other. There we go. So you'll often see these things arranged at opposition, 90 degrees to each other wherever they can. And that's just because of the way that the magnetic fields arrange themselves around these. They don't do a very good job at passing energy at right angles. Versus if you put them parallel like this one, they do a very good job of passing energy that way. But again, I'm afraid I can't tell you what each one of these things does just by looking at it. I'm not that clever. But I can tell you that by the time we get all that stuff, from the left side of the board over to the right, by the time we get over here to this ATI Theater 314 made out in Singapore, by the time we're done with all that, we've got a digital signal that's ready to do stuff. So it looks like almost all of those pins are ground. No, they're not. The ground wraps around them. They're separate. Okay, that makes more sense. I was just misinterpreting it. So, anyways, that is inside of a Tivo as much as I can get inside of a Tivo. And I got to use a hammer, so life is good. With that, thus concludes another hour of Mark Voids a Warranty. I'm Mark. That was a Tivo. This is the Warranty Voider. Well, one of many. I've got a hammer collection now. I hope you enjoyed it. We try to do this every Friday. Sometimes you can learn more from a board layout than others. But I hopefully can show you something each time. It's not always the case. Today, our desoldering didn't go very well, but it was a lot of pins. It does go better if I had more heat or more time, and neither one of those were really an option. But each Friday for the next 3 months, we've got stuff stacked up. So join me at noon Pacific, and we'll take something apart. Oh, one other thing. We're desperately close to 500 subscribers. Once we get to 500 subscribers, I have this ginormous studio broadcast lens that I'm ready to take apart with you live on the air. But we got to get to 500. So tell your friends, tell your neighbors, tell your friends' neighbors, tell your neighbors' friends to watch Mark Voids a Warranty, or come check out some of our other offerings at Teach Me PCB, Advanced Assembly. We've got educational videos, Royal Circuits. We've got webinars and all sorts of good stuff. Sign up. Love to see you.